Assalamualaikum and good morning to our fellow viewers. Today we are going to talk about threads. First of all, the notation of a thread.
A thread is a basic of unique CPU utilization. Example like thread ID, counter, register set, and stack. Each share belonging to same process and code section. Like another operating system such as OpenFile and Signal. Next, motivation have two different types. One single thread process, two multi-thread process. Example, web browser have two different types, two different threads. One thread display, two thread retrieve data. Next, multi-thread server architecture is a web service process. The server will create a separate thread destined for client request. When a request is made, rather than creating another process, the server creates a new thread to service the request and resume listening for additional requests.
Next is multi-core programming. Before, in the earlier days, the old computer uses single CPU system, which has evolved to a multi-CPU system, which is multi-core and multiprocessor, which is multi-core and multiprocessor. For as one core can only process one thread at a time. Thus, increasing the number of core will increase the number of thread will be processed at the same time. So, if there is two core in a computer, the first core will process the first thread, and the second core will process the second thread. As it go on, the first core will, after the first thread, it will continue on the third thread, fifth thread, seventh thread, ninth thread, 10th, etc. According to Amdahl law, which identifies potential performance gain, the speed is depending on the number of processor. Thus, in increasing of number of processor, will speed up the thread processing. So there are 5 steps on designing a multi-thread program. First is identify tasks. This involves examining application to find areas that can be divided into separate concurrent tasks. Ideally, tasks are independent of one another and thus can run in parallel on individual cores. So after we identify which task is in parallel process or individual, next is to balance which is equal to work and value. So each task need to be in one core. So it has to be equal work for each core and equal value. We don't want to put less dependent tasks at a different core. Next, data splitting, and another is data dependency, and lastly, testing and debug. So there are 2 types of parallelism, which is data parallelism and task parallelism. Data parallelism, as you know, is more to data, the resources it be used at the same time. And task parallelism is more on the task and the thread, which is the process itself. So
next, multi-threading models. The user thread must be mapped to kernel thread by one of the following strategies. First strategies, many-to-one models. Many user-level threads are
threading, creation and management of threads done by compile and runtime libraries rather than programmers. There has three methods of the implicit threading. For the first, thread spool, OpenMP, Grand Center Dispatch. Other methods includes microprocess threading building block (TBB). For the first method, thread spool, create a number of threads in a pool where they await works. For the advantage, usually slightly faster to service a request with on existing threads then create a new threads. Separating tasks to be performed from mechanism of creating tasks allow difference. Windows API support threads pool. For the second, OpenMP provides support for parallel programming in shared memory environments. Identities parallel regions block of code that can run in parallel. For the third method of the implicit threading is Grand Central Dispatch, allow identification of parallel sections, block placed in dispatch queue, and lastly, there has two types of dispatch queue: serial and concurrent.
Here, I want to share a little bit about how the thread are implemented in Windows and Linux system. First, I will explain about Windows thread. Windows implement the Windows API, which is the primary for the family of Microsoft operating systems such Windows XP and Windows 7. A Windows application runs as a separate process, and each process may contain one or more threads. Windows use the one-to-one mapping, where each user labels thread mapped to an associate kernel thread. The general components of a thread include thread ID, register set, user stack and kernel stack, and private storage area. Meanwhile, Linux provides the fork system call, which is the traditional functionality of duplicating process. Linux also provides the ability to create threads using the closed system call. However, Linux does not distinguish between processes and